Good evening. I'd like to introduce DJ from Cape of SANSA. He's an electronics engineer there. He spent for and that island called Marion Island, halfway between Antarctica. Can only be a fascinating talk, and I'm sure we look forward to something very good. Thanks. Go ahead.
Thank you very much.
How do we get rid of this?
I think if the audio is off. I think you can mute your laptop. The echo won't be there. All right, good evening, everyone. My name is DJ from the Lake. I'm an electronics engineer for SANSA and the Space Science Division. So we are located here in Hermanus, and my talk, what I'd like to share with you guys today, is my time on Antarctica, basically, how we live on Antarctica and the science we do there as well. Sorry about that. So firstly, where is Antarctica? Or yes. So SANAE IV is our research base in Antarctica. It's actually located, well, where that's, this bar is actually in the way now, but it's basically below the pause button over there. The way we get to Antarctica is through the SANAE II research vessel. It's an icebreaker owned by the Department of Forestry, Fisheries and Environment. So the voyage down to Antarctica from Cape Town is roughly 14 days, depending on the amount of ice build up around the continent. So the vessel would actually carry all our logistics, the cargo team, the PWD team that maintains the SANAE IV base. So these are just pictures of the SAE Agulhas at the ice shelf. So this picture right over here is actually the Agulhas next to the ice shelf, which can give you some indication of how big the vessel actually is, with a small snow tractor right on top of the ice shelf. From there, to actually get to SANAE base, this is the SANAE IV base, which is the fourth base for South Africa in Antarctica. So we would travel with snow tractors, basically cat challenges, from the ice shelf, which is about 180 kilometers. These snow tractors only can travel with a full load of 3 sleds, which would either be a 25,000 liter diesel Bowser tank. 3 of them, they will travel about 13 to 15 kilometers per hour. So that whole traverse from the ice shelf to SANAE base would take between 18 and 23 hours. So it's consecutive driving, very slow, but it's experience of a lifetime. This is also just another, how can I say, perspective of the SANAE base with some snow on top. Then how basically we get water to the base. As most would know, it does not actually snow, rain in Antarctica, which is rather considered as snow. So for us to get water to the base for cooking, for showering, for general cleaning, anything that you would use water for, we have a snow melter. We call it the SANAE, which is basically located just below the base. From there, we would shuffle snow into chutes. So these are two pictures in the middle of the day, and in the middle of the day again in midwinter when there's no sun at all. So it's complete darkness. If we run out of water, we have to go out, shovel some snow so that we can at least cook something to eat or have coffee. The water in, how can I say, there's melted snow essentially is not water. It does not have the properties, the minerals and nutrition that you get from your normal tap water. So this is literally just melted ice. It does not quench your thirst, and as I mentioned, there's no minerals in it. So you do get dehydrated very quickly in Antarctica. So it is highly recommended to take extra vitamin supplements or dehydration supplements as well. As I mentioned before, the image on the right-hand side is the Challenger, the snow tractor we use to do the cargo work. So this is one of the trips I did myself, driving one of those tractors for about 18 hours, literally straight, following a GPS, driving through snowstorms where you can't even see the hood or the bonnet of the tractor. You literally drive by following a dot on a GPS. The picture on the left is one of the bulldozers we use to move snow around. So this would either be used to move snow away from the base, creating huge sastrugies, which is a small heap that's hindrance to other vehicles or people. And obviously we use it to move snow into the snow smelter. Yeah, these vehicles are fairly old. They're about 30 years old. So we do have year-round diesel mechanics that maintain these vehicles. So then getting on to space weather, basically. So that's the whole reason why we, as SANSA, is in an isolated, remote place such as Antarctica. Antarctica does not have any interferences of human life, other technologies, society in general. So what we as SANSA do on these remote stations we focus on space weather studies. So space weather, basically, we focus on the area between the Earth and the Sun. We want to know what the Sun is actually doing. So the Sun would have active regions that are constantly monitored by researchers at SANSA and globally. These active regions would, at kind of forecasted and unpredictable times, erupt, causing a solar flare. With these solar flares, a huge amount of magnetic energy is released with that flare. When it's released towards Earth, our instruments in Antarctica can pick that up in real time before it actually affects any systems. So basically, yeah, a solar flare would be a sudden burst of huge amounts of energy. we basically look at certain spectrums of solar flares, and these would vary with the class of solar flare. The most intense class would be a X class, where these X class solar flares would essentially affect day-to-day life. In a sense, it can affect astronauts, satellite communications, GPS satellites. It can even hinder electrical grids. So that being said, if a solar flare or coronal mass ejection, which is the wave produced from the solar flare, would hit a scintillation satellite or a GPS satellite, Garmin or TomTom would lose that satellite. In a sense, your GPS on your phone or the older model GPSs would lose some data points. Same with airplanes or the International Space Station, that can also be affected. The beauty of a solar flare is we, as humans, are treated to the northern or southern lights. So they only occur on the poles of Earth. So this is an image of the one aurora or the southern lights in Antarctica. The colors differ from the northern and southern hemisphere, so that's dependent on oxygen and nitrogen precipitation in the atmosphere. Where in the southern hemisphere you would get more green colors, in the northern hemisphere would be more purple towards blue colors. So yeah, this is actually the first aurora I've witnessed, which is the top photo. It's a little bit blurry. A aurora is actually, it looks like a pastel painting in a sense. I don't have a pointer, but that's to be like a star. So I was actually nervous when I took the photo, because it was unfolding on top of me. So it's difficult to look at the camera and be in awe of this aurora just unfolding in front of you. So you're standing there with the camera without taking the photo. You forget to take the photo. And then obviously myself, later during the year, again in front of SANAE base. So the aurora intensity would vary depending on, the strength of the solar flare that's either happened a few hours earlier or a day earlier. Then the other instruments, or I can basically cover all the instruments we have in Antarctica. We have rheometers, which basically looks in the ionosphere. All our instruments are focused on the ionosphere. So the rheometer would look at irregularities in the ionosphere. Same with our other instruments, which are the VLF monitors, the HF radar. They also basically focus on the ionosphere for any irregularities. We also have the magnetometers. So the SANSA site here in Hermanus is known as a magnetic observatory, meaning it has 3 magnetometers. So it's considered the observatory where SANAE will also, or Antarctica will also be an observatory. So it's magnetically clean enough to collect usable data from the Earth's magnetic field. So there we actually look at any disturbances in the magnetic field, whether it's shifting, how it's behaving, any external disturbances, which is also done here at Hermanus site. The data used for that, the reason we do that is, firstly, it goes for researchers, universities, and to calibrate instruments. So any seagoing vessel, airborne vessel, needs to have a old school, essentially old school magnetic compass, not digital. Digital are allowed, but a proper calibrated magnetic compass, and that's what we can do here in Hermanus. We can actually calibrate those compasses, which need to be done on an annual basis. That's to mitigate any irregularities or changes in the Earth's magnetic field. So the compasses would be calibrated according to that. So even submarines with their instruments, it will also need to be calibrated. Then we have GPS receivers as well, basically looking at scintillation events, again, in the ionosphere, and also tracking of satellites. We also look after a seismometer. So the seismometer would basically, sorry, I was teaching it. The seismometer would essentially look at any disturbances in the vicinity of SANAE IV. So the seismometer does not belong to South Africa or SANSA. It's part of a global non-profit organization, which is a treaty for anti-nuclear testing. So it's just to make sure that South Africa or anyone in that vicinity, which would be ourselves, the Germans, the Chinese, don't do any weapon testing. This is just an image of one of the rheometers. This is specifically an imaging rheometer. So my role specifically was to look after all these individual instruments and make sure they collect usable data and that the data is actually being stored. It would also be required of myself to upgrade these instruments, write new software, or physically repairing or upgrading systems. Yeah, so this is a rheometer antenna. Then we have one of the flux gate magnetometers at SANAE. These are buried in ice so that there aren't external disturbances such as the personnel staying over for the year or any vehicles. Well, either way, that area is demarcated. One of the bigger projects is the VLF monitors, which is basically a diamond-shaped antenna. One loop faces north-south, and the other loop of the antenna faces east-west. These antennas basically transmit at very low frequencies to the opposite hemisphere. So that would go to the UK, to America, Brazil, different countries that have receivers. So as soon as there's a solar flare, in a sense, we will be able to pick it up with this antenna. So the disturbance in that signal found in the ionosphere, we will be able to see that. What would happen during the year when we experience a storm in Antarctica, which would be winds up to 210 kilometers per hour, it would literally rip these antennas apart. So this is a photo of the first time it's happened in my year. So you can see it's fairly damaged, and it's not possible to just patch it. We had to reconstruct the whole antenna. So it was myself and another colleague. And there's my colleague, very happy with the new antenna after about 6 hours work outside, which happened in this instance 11 o'clock in the evening till about 4 or 5 o'clock in the morning. The reason for that is it was getting close to midwinter, meaning complete darkness, and that was the only time the wind was calm enough for us to actually go outside. Yeah, so as I mentioned, the VLF antenna sends very low frequencies to the opposite side of the globe, basically ranging from 19 kilohertz up to 25 kilohertz, where we look at the interferences of those signals. So this is one part of the VLF antenna, essentially what's its capability. So this is two different frequencies, 19.5 kilohertz and 22.1 kilohertz. So this is both from the east-west loop, and we only look at essentially daytime, even though in Antarctica it would be daytime 24 hours, depending on which time of the year. So the areas marked in red circles, that's actually how and where we can see a solar flare occurred. So it would disturb that signal. Yeah, then if I can move on to the HF radar, which is, how can I say, the biggest project for SANSA in Antarctica. The HF radar also focuses on space weather studies, so it's mostly used for research. It has been, how can I say, it's the first radar for an African country, and it was first implemented, the new setup was implemented in 2010 and then upgraded in 2014, but the first actual radar was built in 1997. The radar is part of a global network. So SuperDAN stands for Super Dual Auroral Radar Network. So that's a global network of HF radars. HF meaning high frequency, so this would range from 8 megahertz to 20 megahertz. In that frequency range, we are able to transmit with this radar. Currently, there's about 16 different countries in the South Pole and North Pole, part of this radar network, and that's a roughly 32 different radars. Yeah, so this radar basically was our main priority. In a sense, we also had to take care of this radar. So it consists of 16 masts, 16 antennae, each mast being 18 meters tall in this sense. So we, myself and my colleague, if an antenna broke, which is this diamond shaped antenna, if the photo was a bit larger, these are runs that we use to climb up. So it would not matter what weather conditions were, if the radar was off, in a sense, if an antenna broke in a storm, we had to climb in bitter cold to fix that. So that was also quite an experience where your gloves would actually freeze onto the runs. We had actual hand warmers and proper climbing kit to climb, but it is really, really cold. But I wouldn't exchange it for anything because of that experience. There's just another photo of the radar array with the SANAE base in the background. So the radar can actually transmit from SANAE 3,500 kilometers away from base. So that's our transmitting range. During this past relief period, which was now from December until February, which I just returned from about 6 weeks ago, we upgraded the radar for the first time in 10 years. By saying that, new software was implemented, new electronic boards were constructed, or rather modified in that sense. So the radar runs off a server rack, which are these transceiver boxes. So each box would be connected to an individual antenna. As I mentioned, there are 16 of them. With the upgrade, we implemented a secondary array, which is 4 additional antennae. So these required 4 additional transceiver boxes. The reason for the secondary array is it gives us elevation data of the beam essentially being transmitted. Part of my role for these transceiver boxes would be to, to calibrate and service them. So this would be a typical setup of our transceiver boxes in the lab, where we would service each board, each board on component level and make sure that it transmits and calibrates correctly. Then with the secondary array, which is also known as the interferometer, the masts were, at some point, it was installed at Antarctica, but during the years of storms, the masts actually fell down. So myself and my colleague physically lifted the masts during the year, and when our takeover team, the SANSA team, came for the relief period, we managed to get the antennas up with a cherry picker, which is the image, the top image. So the radar with the array, as I mentioned, will be able to give us elevation data after we calibrate it. So this would be then used for power. I can say the data we collect would be power in the sense what we transmit, Doppler velocity, and spectral width. This is just another image of the actual secondary array complete. So the bottom image is where all the masts are up with all the antenna also connected. Then just to show the difference, the plot on the right-hand side is the radar without the secondary array, showing power, velocity, and spectral width. So this is when it's transmitting and the data we receive. Then on the left-hand side, the fourth plot would be the elevation data. So in a sense, our team were successful in commissioning this secondary array. Then this is just to illustrate the coverage of the various superdome radars we are part of. So the southern hemisphere here on your left shows the various countries and ourselves at SANAE with the cover range as well as the northern hemisphere. Then small things we picked up during the year in Antarctica, such as a phenomenon I personally haven't experienced, which is the image in the middle, which is known as a light pillar. So if I could, that is the base, which is very small, so that is a few kilometers up. This phenomenon happens when snowflakes are in parallel with a light source or the Earth's surface in a sense. So all along the base, there are lights. So those lights are then basically refracted straight up. This was also experienced very, very early morning hours. I think it was maybe like 2 a.m. while working outside. Then just again, top right-hand side is a close-up image of a snowflake on a handrail. Then the Antarctic base with a aurora, and myself and my colleague at the bottom of a nunatak, which is where the base is situated. Then the team how can I say, the overwintering team at SANAE comprises of 9 people. So we would only be 9 individuals for the overwintering period, which is normally from the middle of February till December. It's only 9 people that you live with. Essentially 9 strangers, but you do become acquainted with each other. You do become lifelong friends. So we would make turns to cook. So you would cook basically for 9 people, and after 9 days, you would cook again. Lunch and supper would be your own. Everyone essentially had their own routines, what they followed during the day, whether it be a weekday or weekends. All our food is canned or dried food. No fresh produce is allowed in Antarctica or at SANAE base. So even eggs need to be irradiated before they're allowed to actually leave the vessel. It's just so that any kind of bird flu that might arise from it does not get into the area. So radiated eggs or eggs in Antarctica, just because Antarctica is essentially a desert, so the air is very dry. Eggs would literally turn to powder or a jelly substance. So if you would break an egg, it would be a hollow egg with this piece of yolk still sticking there. So our eggs didn't really last very long. In that sense, we would have powdered eggs, which do not taste very nice. Other than that, we have frozen meats. All our meats are frozen. Essentially, we have, or SANAE base has enough food for 2 years. In the event something would happen, if the ship can't reach Antarctica, whether it's too much ice or there's something wrong with the ship, because South Africa only has 1 icebreaker, the team that is there has to be able to survive for another year. Yeah, we would process all our own waste. So glass would go separately, tins, metal, everything would go separately, crushed and then placed into basically used oil drums. Those oil drums come from the diesel generators that power the base. So the whole base is run off 3 diesel generators, so they are continuously running 24/7. Therefore, we have 2 diesel mechanics on standby, on rotation. Then we have a diesel bunker basically supplying these generators to run continuously. Other vehicles, as in the photo, we do have snowmobiles, canoes, which are relatively old, but really a joy to drive around with or play around with. Yeah, we don't have other vehicles than that. So, yeah, I think that's me. If there are any questions, please ask. Yes.
You pick up depressions over the winter?
Yes, we do. So we have a common terminology known as T3 syndrome. So a T3 is a hormone or a chemical in a person's brain, and the lack thereof would cause depression, anxiety, things like that. So that is due to the lack of sun, especially during the dark periods, dark months, which is roughly 2 months of complete darkness. Fortunately for us, our team was mentally strong enough, so we did not have any, how can I say, outbursts of personalities.
You take off the 9 overwintering teams, 2 were okay. What were the other 7?
Yes, yes. So yeah, sorry about that. So we have a medical doctor, so a normal GP. She's actually a veteran. She's well known in the program. She's actually currently still there. It's her 7th year overwintering at SANAE. Then we have a radio technician, a electrician, instrumentation technician, a South African Weather Services meteorologist, and yes, myself and my colleague. Yeah.
On that same subject, what about interchangeability of personnel? What if one goes off sick? And is there anybody else that they go from a standby base?
Yes. So it depends on who the person would be in a sense. If the doctor fell sick, that would be kind of challenging. We do have, I can say, good relations with Germany, which is a troll station. They about 300 kilometers away from us, which would take about 2 days to get there. So if the doctor would get sick, we would just encourage it to not be sick too quickly. So no, but the other personnel, technical personnel in that sense, the diesel mechanics, the electrician, the instrumentation technician, they essentially all work together. So they need to understand the whole operation of the base, whether it's the wastewater treatment plant, the water filtration plant, the diesel generators itself. They all are supposed to know what's going on. So they are capable of assisting each other. Yes.
Do you have any limits on
Not at SANAE itself. So SANAE is quite barren in a sense from wildlife. There is a bird colony known as Robert's Column, a few 80 kilometers from us. But on the way to the ice shelf, on the way to Antarctica, we were able to see Ross seals. Leopard seals weren't seen in our year, but they have been seen before, and we were able to see Adelie penguins, I think the small penguins. They are the emperor penguins, the biggest penguin species, which is about that time. Their colony is quite far from us, so the idea is obviously not to disturb. So unfortunately, on SANAE, we just have ice on that side. Ice on that side. So, yes, ma'am.
What process do you go through, what tests in order to be able to go there? I mean, you can't just say you want to go. Do you do medical tests, physical tests?
Yes, well, yeah, that's a good question. That's the first thing to decide if you are willing to go. But we do go through a rigorous medical examination, a psychological examination, and then in my case, it depends on your qualifications, basically to work for SANSA. But there's no age restriction on going to Antarctica. If you're medically fit, if you're physically fit, if you're mentally fit, then you're allowed to go. So all those tests are done to consider whether you may go or not. Yes. So in our year, in midwinter, which would be from May to August, I think it was in maybe June, it was negative 43 degrees. So the actual degree in temperature is not that cold. It does not feel that cold. Where the cold actually comes in is with the wind chill. So as soon as the wind would pick up, if you would be outside at negative 10 and the wind would be maybe 25 knots, the actual wind chill temperature would be negative 45 degrees. So that's where frostbite starts creeping closer.
How many people are there over the summer period?
So the summer period, it varies, but it would be between 50 and 70 people at the base. The base can house 80 people comfortably. Yes.
I didn't quite understand what the function of that superdome radar is. What does it actually measure? Why?
Okay, so the superdome is used for space weather studies. So with all our other instruments, we look at the ionosphere. So the superdome would transmit basically in a pi format. This transmission then looks at any irregularities in particles in the ionosphere. So that's why we transmit between 8 and 12 megahertz. So then that data is used for space weather forecasting. So the Space Weather Center, at SANSA, the forecasting sensor, in that sense, they would use that for forecasting space weather events such as solar flare intensities, magnitudes of coronal mass ejections, or it's either used for scientific papers in a sense to science.
Are your
No,
is there any chance of putting up a webcam like that?
so we do have satellite internet. It's just very old in a sense. Unfortunately, we don't have Starlink. That falls under the government. So we as SANSA are not, in a sense, responsible for that. We are able to send emails, WhatsApps, and depending on whether we can make a video call, but streaming social media such as YouTube is not possible. And we also have satellite phones in the event there's an actual emergency, then we can contact Cape Town or any of the other places.
So the aurora, and how long do they last?
Yes, so the auroras, we were actually quite blessed in our year. We had one almost every second day. So a aurora, dependent on the strength of the solar flare's mass ejection, in a sense, the strength of the magnetic wave from the solar flare would determine the intensity of the aurora. So that would vary between literally 10 minutes or 3 hours. So you would stand there and see a little bit of green and think that's it. And then you just wait 2 minutes and then the whole sky lights up. So it varies, yeah. Yes.
The ozone layer that holds the Antarctica, does that have any effect on the health and safety for you?
Not that I'm aware of, or I haven't felt the effects yet, so I'm not sure. We're not, yeah, I actually have no idea. Yes, sir.
But you circles you had showed the big jumps in space. There was one that also came down as much, which wasn't lead to a gap. Huge drop there. It's quite steep.
Sorry, are you referring to bottom graph?
No, sorry, top one. Yeah, between that is the sudden drop at the top and the highest.
These are two separate graphs. So that's, yeah, so that's 24 hours from there to there.
Yeah,
And then
one of these.
yes, so these would also be always very big interruption, so that could be a solar flare. So on this side, that's why we really look at the daytime, just from 7 in the morning till 5 o'clock. We don't really, in a sense, care what happens.
So on 24th of March, you had an 8 or something. It would be the highest in the week.
Um,
I tried that.
yes, you'll see it very distinctively. So it would appear the same, but it would definitely be much bigger. Yeah.
What is that in terms of height of the current effect?
From these plots, I'm assuming you're asking the strength of the solar flare. Yeah, so from these plots, we can't actually determine that. So this only, in a sense, shows us that a solar flare did occur, but we can't, in essence, say what kind of class it was, the strength of the solar flare. So we do have other means of doing that. It's just in this case, with this instrument, we can't do that. Yes.
How have you found the climate change on the ice, on the snow, on the conditions around it over a period of years?
I myself haven't, in a sense, experienced Antarctica before. So the British Antarctic Survey, they actually work explicitly with climate change. As I understand, the ice has been melting. So in our trip down to the ice shelf, the ship did not actually need to break through any ice, meaning the temperatures has risen over the last 10 years. So it's not as cold as it used to be. So during the summer period, we would actually be able to have short sleeves on or actual shorts. It's just the sun would be so intense, you would actually be sunburned. But that's what I mean by if the temperature is -10, -15, you can still have short sleeves outside. Just as soon as the wind picks up, then you start getting cold.
I see those buildings of yours all stuck on stilts.
Yes.
Is that keep them cooler? Keep them warmer?
That's mainly to keep them out of the snow. So the previous, so yeah, those stilts basically, it's to keep it out of the snow. So snow would build up. If I can just go back to that previous photo. So snow would build up during the year, which is over here. So as you can see, that all completely varied. The reason for the base being on stilts is so that the base doesn't get buried, and this is the actual first base, research base for South Africa that's above ground. That's why it's called SANAE IV. SANAE 1, 2, and 3 were literally tunnels underground. So there they were already under snow, which makes things very difficult. So SANAE 3 actually caved in, which is a safety hazard. Where SANAE 4, we won't have that problem. With this being said, if the wind picks up to about 60 knots and above, the strongest we had, I think, was 98 knots, which is about 210 kilometers per hour. The whole base would shake. So it would kind of feel like an earthquake, like it's like a rigorous vibration throughout the whole base. But the base is fairly strong. So
what's the predominant wind direction area of?
It
goes along the length of the body, 90 degrees to it.
Yeah, it goes basically 90 degrees against the body. Yeah. The wind does vary, so it depends on what kind of storm base.
Any more questions?
What meteorites? Do you pick up any meteorites lying on the surface around your area?
No, fortunately not. We can see meteorites within the area, I can say in near space. So sonar with the path a meteorite travels, we can use that to calibrate the instrument. But that's the closest we come to meteorites. So the secondary array, which is the interferometer of the HF radar, the path of meteorites, we can actually use that to calibrate the secondary array, which is used for elevation data of the beam. But yeah, that's the closest we come to meteorites. Yes.
You ever experienced the personal training devices? And if that ever occurred,
Yes, so that is definitely a risk. I was one of the station leaders, and I was also the leader for SANSA and for our summer team as well. So as any work environment or modern work environment, you would have your politics and drama that do arise. So you just have to handle that in a professional manner. But yes, we do have instances where we try to actually keep it quiet. But it's like any other work environment. There are people that disagree with each other. Not the sun specifically in that sense. For the, can I say, the magnetic observations we do with the magnetometers, we literally just look at disturbances in the magnetic field. So in a sense, if I would walk past one of the magnetometers, it would essentially give a spike in its reading. So that's basically what we monitor. And over a certain period of time, which would be in years, we can gather, or the data acquisitioners at SANSA can gather whether the magnetic field has shifted or not by 0.001 degrees or something in that sense. But no, we can't see the movement of the sun in a direction.
All right, thanks very much.
Thank you, everyone.
Fascinating, and all of us appreciation. I see you wrapped it up, so you can't see how expensive it is.
Thank you very much.
Just a couple of little announcements. Somebody dropped some money at the door, which David picked up. If you can really... Sorry, it was me. Okay. And you got the currency right. Unfortunately, it's not Europe, but Australia. Just another little announcement is once Skyline is cleared, if anybody's interested, we can give it for a discount. So, thanks very much for your attendance, and look forward to seeing you next time. And presumably, the recording on YouTube of this session will be available if anybody wants to see it. Thanks very much. Thank you.